In the previous video we have learned two methods. We have learned three types of methods to find out the center of gravity. We were discussing how we can find out the center of gravity using geometrical considerations. We have only taken one figure, that is this figure. This is a rectangle. How can we find out the center of gravity of a rectangle? Okay, now we will come across different figures. We also have a triangle. For example, this is our triangle. How can we find out the center of gravity of this triangle? Now we know that this is our axis. Now remember that this is our axis. Now we are coming towards this distance. The center of gravity, for example, is this. So geometrical considerations say us that if we are coming from this side of a triangle, so in x-axis the center of gravity will be equal to this distance will be 1/3 of the whole distance. If this is whole is b, if this whole is b, then this distance, which I can show you in a bit black, this distance will be 1/3 of b. 1/3 of b. Okay. The same goes for from this direction, or from this direction. This distance will become b. Now this distance will become, I can show you in a bit different color. So this distance will become 1/2/3, actually 2/3 times b. So this is the geometrical consideration says that the center of gravity will be, from this side it will be 1/3 of b, and from this side it will be 2/3 of b. Okay, there are more figures and solid bodies, as the geometrical considerations say us that reveal us how can we find out the center of gravity of these objects. Now look at this trapezium, or we usually call it a trapezoidal figure. You can see that to find out the center of gravity from this distance, from this, the thickness of marker is a lot. I can close it now. Now this distance is, it is shown here that it is h/3b, and what is h? This is h and this is b. Now we are coming towards the center of gravity of a semicircle. You can see that this is our semicircle. This is our semicircle, and this is the distance 4r/3π. And what is r? Its radius. Now this is our semicircle. If we are considering is a full circle, then definitely this. If we are coming from this side, then from this point toward the center of gravity distance will be, we can find out r. We have this, we know this distance. So to calculate the opposite distance, we will definitely minus r minus. So I can write this r minus 4r/3π. Quite simple. Okay, so we don't need to read the whole circle. The semicircle gives us the complete concept to find out the center of gravity without going to read the whole circle. Now another figure, it is our circular sector. You can see that, and even take the screenshot if you are solving any type of question where this kind of figures come. Hemisphere also the same concept as I have given in the semicircle and circle. It's hemisphere, and to find out the center of gravity in full sphere, you just need to minus r minus, or you have to check from which direction you are coming in. So we have another solid body. Now these are solid bodies. Hemisphere is a solid body. Right circular solid cone, it is a solid body. Segment of sphere. Now in previous we have a half sphere and full sphere. In this figure we don't have half sphere, we have a portion of sphere. We can say that it is a segment of sphere. So this is a segment of a sphere, and to find out its center of gravity we have this formula: 3 upon 4 2r minus h whole square divided by 4 3r minus h. So this is our whole concept, how geometrical considerations work out. Okay, to find out the center of gravity using geometrical considerations, we initially have for rectangular h by 2 b by 2 means half of the distance. For triangle 1 by 3 of b and 2 by 3 of b. From either side, from if we are coming from a larger side like longer side this, or from shorter side it will be 2 by 3 of b. And the other figures I have already shown you, you can see that once again. So this was our whole concept of geometrical center of gravity for geometrical considerations. Now going towards our by moments. The concept of moments come across only when we are finding the center of gravity for composite figures. What I mean by composite figures is quite simple. Means a T-section. T-section is usually a beam sections. T-section is used as a column cross section in steel structure and other structures. Usually the buildings that are the skyscrapers and other buildings that uses T-section as their column to find out their center of gravity, we use this composite method. This is a composite figure, so to find out the center of gravity of a composite figure we use this moments by moment formula. So we have I can say that we have this to initially we need to place the axis, so this will be our axis. It is not clearly shown. This is our axis. As close, place this as close as you can. Okay, now to find out, remember one thing. What is this x1? This is the figure of T-section consists of composite sections, means more than one shape. Now this is our first section, this is our second section. So you also have to name these sections. You have to divide these sections. The upper portion is first section, the second this web and this flange. The flange is first section and the web is second section. So A1 means area of first section and x1 means center of gravity of first section. Now with respect to this line, this axis, what is the center of gravity of this? It's quite simple. The center of gravity will be initially this distance plus, according to geometrical considerations, half of this distance. So we can find out the center of gravity of first section. Okay, now this will be x1. So by movements we can actually find out the center of gravity of a composite section. We have these formulas we will apply. You can more understand this concept when we will come across this problem. We will use this formula to find out how we can find out the center of gravity of a composite section. Okay, now coming back towards the methods to find the center of gravity. Now we have learned all these three methods. Actually I have not taught by graphical method because it only contains academic value. Whenever an examiner asks you how many methods are there to find out the center of gravity, you can say that there are 3 methods. Whenever a teacher asks to explain the procedure for a graphical method, you can simply reply that graphical method only contains academic value. It is not practically used. This is a tedious and cumbersome.